Hello everyone, in this video I'm going to show you how I put together this ATU-100 antenna tuner from the November 7th Delta Delta Charlie design. I'm going to show you how I created the toroids and the coils and where you can find all the information. At the end I will show you a test that I done with one of my rigs. Hello everyone, if this is the first time watching, my name is Pablo, call sign VA3HDL. If you like the content, please consider to subscribe. That is going to tell me that you like what I'm doing and give me and encourage me to continue producing videos and content for you. In the video, we are going to cover this tuner that we have here on the desk that I put together, this kit, and let me tell you how we are going to do that. First, we're going to take a look inside at the tuner. Then we're going to explain how to build the inductances, coils, and toroids. And if you have a NanoVNA, I'm going to show you how you can measure them. Then I'm gonna test with the radio and show you what purchasing options are out there for this tuner. And at the end, I'm gonna show you the matching capabilities that this tuner has for each one of the ham radio bands. I mounted the board on the top of the case, as you can see by those 4 screws in here. So let me pull the top of the case open. Right, and let's see what is inside, what we have inside. I use this standard SO 238 connectors instead of the SMA connectors that come with the kit. Those are better for my station. Everything I have, I use PL 259, so those are the standard connectors. And as you can see here, in the front we have the 3 buttons. There is one button that comes with the kit that is wired. The standard button, which is the tune button, is wired here. And the 2 optional buttons, those 2 buttons, they are optional, are wired on the bottom of the board. Those 2 optional buttons are the bypass and the auto buttons. Then on the front, here I have the OLED screen. The OLED screen is attached with 4 screws. And in the back of the case, there is the power adapter, the power connection, and like I mentioned before, the SO239's female connectors for the RF. So this is a very simple setup. Of course, I'm going to use this for 100 watts, so it's always better to use for RF a metallic case. In this case, it's an aluminum case that I found a very reasonable price on Amazon. So in the next part of the video, we are going to cover how to build the coils that we have on the board, the different coils, and what tricks we can use to build them correctly. So after I done a couple of presentations for the local clubs, the local hams, they were asking me how they put the coils, the inductances together. So the information that is provided, you can see here on the circuit, the only information that you have available about how to build the coils is provided here. There is the bill of materials here, right in the middle of the screen. In this part here is in this part you have how to build the coils. Okay, so it's very limited. People miss this. They cannot find. They don't know where are the instructions. So I'm gonna go step by step on those instructions, and I'm gonna show you some tips and tricks. So those are the 7 inductances that this circuit uses from L1 to L7, and it also uses a tandem match, which we're gonna cover at the end. So for those standard toroids and coils, here are all the specifications, and I'm gonna leave it a couple of seconds so you can take a look, or you can pause in here the video and capture this. Also at the bottom here on many slides I have the website of the author, November 7 Delta Delta Charlie David. Okay. This picture was sent to me, was shared by Paul Morfield, Victor Alpha 3, Foxtrot Uniform Zulu. Paul sent this to our group with a trick that he used to build the coils. I use very similar trick. For the 4mm coil, he used this screwdriver as a base for the coil. For the 6mm coils, he used a 1/4 inch phono jack, as you can see here. And he showed us, and Paul is showing us here in this picture, the L4, L5, L6, and L7. So those two are the double toroid. Those has 2 cores on each. The tandem match is probably the most difficult one to build, and is probably the one that most people has questions on how to do it. So this one is a dual transformer 10-to-1. So those are 2 transformers. So if you look at this is one transformer, and this is the other transformer. So each one of each side of this tandem match is one transformer, and each side it has 10 turns of the thinner cable, the yellow orange cable in here, and 1 turn, which is this one thicker on the middle, in going through, right? So the middle one, the thicker one, is the one that the RF is coming and going through the radio and to the antenna. And the orange one is the one is getting the RF for measuring purposes, as you can see here. So it's very important, and do not overlap the turns. As you can see here, there is no overlapping on any of the turns. Those are perfect turns, as you can see them here. And have this internal conductor in here is the center conductor of a coaxial cable. It can be used. You can use any cable, but a center conductor of a coaxial cable works fine. And it's important to have a very snug fit in here, so that prevents the turns of this part of the transformer to move and overlap or go out of place. How we can measure now the coils? You can do that only if you have a NanoVNA. You can use this process. So in this process, what I did is I put together this little perf board that it has in parallel with the coil. It has 200 ohms resistors, that is 50 ohms when the two are in parallel with the coil, and connected to the channel 0 of the NanoVNA. In the NanoVNA, on the channel 0, we have to set up a smear chart, as you can see here, in channel 0, right? And you can read directly from the screen the value of your coil or of your toroid, right? So the range of frequencies that I use, it was from 1.5 megahertz to 50 megahertz. And it's giving me this nice curve. Of course, it will be better if it goes here, but still is very decent performance for the coil. In here we have a picture of with the first 3 relays installed and all the coils already in place on the board. And the recommendation is to install all the coils first, because when you start putting the relays on this part of the board, then it's going to be hard to solder the toroids if you leave them to the end. In here you can see everything is soldered, all the through hole components, as you can see them in here, they are all soldered, plus the tandem match that I explained before how to put it together, and all the relays. This is the smoke test with a 9 volts battery that I did the first time just to make sure everything works fine before I put it on its own case. So here's the case before I put the board. Now it's with the board in, and now let's do a live test with the radio.
All right, let's do a quick overview of the tuner now. So I just power on. You can see here all the values are in 0 watts, 0 SWR, no inductance, no capacitance, is all in 0, okay? So let's explain a little bit the modes of operations. As you can see here in the front, there are 3 buttons. So what does the first button, bypass? The bypass button is when you're using the tuner, if you press it, you see there is an indication in here, there is an underscore, that means it's in bypass mode. And what it means is it's not using any of the tuning capabilities of the antenna tuner. So it's just bypassing the internals and going straight to the antenna. So we're going to remove now the bypass function. The next button is auto. So to put it in auto mode, we touch the auto button and you see there is a dot in there now on the screen beside the power. That means that is in auto mode. What it does in auto mode is every time it detects an increase on SWR, it will try to tune the antenna automatically. So this is very useful if you're jumping frequencies, that it will be constantly adjusting the tuning and lowering down your SWR. We're going to turn it off. And now it's again back in manual mode. And the tune button, what it does when it's in manual mode is if you press very short, it does a reset. As you can see there, if it's any values already selected, it will reset everything to 0. And if you do a long press, it will put it in tune mode. And what this does, it will wait until you send a carrier to do the tuning. So now we are in 80 meters. I choose this band because I don't have a very resonant antenna in this band. So any movement that I do in the frequency, it will try to tune. So it's good band and good antenna for me to show you the testing. So let's do the first run. So I have the power set at 20 watts. So let's see what happened when I press the PTT button. All right, it did the auto tuning. As you can see here, it lowered the SWR to 1, it's fluctuating a little bit, but to 114, 116, okay? You can see it in there. So when I release, you can see the values of capacitance and the values of inductances that is using. You can see right there on the screen, those 2 values. And now what I'm going to do is very quickly, I'm going to reset. I'm going to show you the reset. So this is tuned. It's not resetting anything there. Now it's reset. As you can see in there, everything is back to 0. And now it's not in tune and it's not in auto mode. So if I press now the PTT button, what it's going to do is it's going to show me the real SWR that I have here without trying to tune. So it's 2, close to 2. So I'm not going to keep transmitting too much. But as you can see from 2, now we are going to put it in auto mode. So now you see the dot in there, meaning that it's in auto mode. I don't need to press the tune button. Like when I send the carrier, it tunes, as you can see in there, and it lowered the SWR to 1.1621. Okay, so now that is in auto mode, I'm going to move to a different frequency. So I'm going to move to 700 in here on the band. And I don't need to press any buttons on the tuner or anything. I just send another carrier and automatically it's going to try to tune. You see? Automatically lowers down again to 1.15 because it's in automatic mode, right? So I'm going to go back to 680 and I'm going to remove the auto mode just to show you. It's not any, but I left the previous values. So to see how much I have in here with the previous values. So in here I have 1.5 SWR with the previous values. So now what I'm going to do, I'm going to put it back again in auto mode and I'm going to send a carrier again. And you see, it looks again. So that is even worse than before. Let's try this one more time. No good. Sometimes you have to do it, you have to do a reset. And let's try it now from 0. Okay, from 0 now it worked better. It found a good combination of capacitance and inductances and is now 1.10. Okay, so this is for the demo. As you can see, it's very versatile and all the options that you have for tuning. I'm going to increase the power to 100 watts and send with 100 watts. So I'm going to pause until I do that. All right, so let me increase the power to 100 watts, which is the maximum that this tuner supports. And let's go back and let's send another carrier and see what happened with 100 watts. All right, that's pretty good. This WR 1-to-1, and you can see here in the screen of the FT9 in the FT857D there is no SWR, so it matches with the reading, and the 100 powers that I'm sending, it matches with the 100 power reading on the antenna tuner. So as you can see, I send that constant carrier at 100 watts. It's working very well. It's very accurate, at least in this frequency, with the readings. All right, so the last thing I wanted to show you is the bypass mode. So let's see how much, I lower the power again to 15 watts, or 20 watts. Let me see how much I lower the power. 20 watts. So it's 20 watts, the radio now. So let me send a carrier. So okay, it's 1.03 SWR right now. And what I wanted to show you is I'm gonna remove the auto and I'm gonna put it in bypass mode. And now it's not using anything. So I'm gonna send, and I have 175 SWR in this part of the band in bypass mode. I remove the bypass mode, and you can see it remembers the last setting, and it goes back to what capacitance and inductance was using before. So if I transmit now again, it's 105. 105 SWR, I put bypass mode, everything goes to 0 because it's bypassing the tuner. I transmit and I have 160 in here. All right. Remove bypass mode. Transmit again. 107. That's good. And that's it for this part of the video.
There are two power on combos to test the unit. One is using the tune, bypass, and auto buttons and power on at the same time. In this mode, the device turns all the relays on, and you can test and make sure that all the relays are working correctly, because you can measure them, of course, right? The other option is to power on pressing the bypass and auto, and then power the unit at the same time. In that way, you can turn on and off the capacitance and the inductance one by one individually, and test everything is working fine, or use the tuner manually, completely manually in that mode. So we're gonna take a look at that now. Okay, let's see if we can do the power on, tune, bypass, auto all at the same time to put the tuner in fast test mode. So we press the 3 buttons on the front together, and I'm gonna connect the power here. All the relays sounds that they connected, and it says fast test on the screen. At this point, you can measure the current that the device is consuming, and with all the relays on, it should be over 200 milliamps. So that's it for this power on combo. Let's try the manual mode power on. So let me turn it off. And for this one, is the bypass and auto buttons that we need to press together, and I'm gonna put the power back on. It says test mode, as you can see on the screen when you boot up. If I can put it a little bit closer so you can see it better. Go. Okay. And now in the simple test mode, we can use the buttons to move the values. So you can see is 5 micro henries. Every time I press this button, it's increasing the value. We hear the relays clicking. All the possible values. If I leave it on, we can see the number and all the relays clicking. And with this button goes down the inductances, and if I press the tune button, instead of moving the relays from the inductances, it switched to the capacitance. And okay, now it's working. So it switched to capacitance, and you can see all the capacitance now increasing, and it's clicking. Let me put it close to the microphone. And capacitance is increasing. That's the maximum. Now we can go back, or we can switch to inductances. You see, now I'm going up inductances, or I can go down on the inductances in manual mode. All right, in this last part of the video, we're gonna very quickly see purchasing options, and we'll see also the ranges that this antenna tuner covers. So first of all, here on the screen, I'm showing the one that I purchased for 35 Canadian dollars, shipped to Canada. You can see there the conversion to US dollars, 0.79, so you can make the calculations. There is also a fully assembled package, as you can see here, completely ready to use, 91 Canadian dollars. There is another option with coming with the ATU-100 connectors. Remember, mine came with the SMA connectors. There is this other option. This is only the case. So you can purchase the kit and the case separately. This is the case alone. This is another fully assembled unit, but the difference here is the screen. Instead of the OLED screen that I have, this comes with a 2-line type OLED screen. This tuner also can be used as a remote tuner by adding a bias T on the input for the power, and you need 2 bias T, right? So one for the tuner and one inside your shack for sending the power. If you want to change the programming inside to tweak it for lower power or for or to upgrade the firmware, mine came with firmware 3.0, but there is the version 3.2 out there on David's November 7 Delta Delta Charlie website now. And now this is the last part of the video. We're gonna cover the tuning capacity for each band. So in 160 meters band, it tunes for, here is approximately 4.4 SWR to 0.4 SWR. So in that range, it will, in this entire range, it will tune. This is a Smith chart. So if you know how to read the Smith charts, here in this part of the Smith chart, you have SWR, and here you have inductance, and over here you have capacitance. So this is what this Smith chart is showing us. So this is how it will tune in 160 meters. As you going higher on frequency, the capacity of the tuner is higher for tuning your antenna, and it has some blanks area that we will not tune, but it probably will go to one of the two up or below. Like you can see here in this range, it will not tune, but it will come to the closer to that range, right? So this is 160 and 80. Same thing for 40 meters and 20 meters. As you can see, is broader now, the coverage. And same thing for 18 meters, 30, that is 17 meters band, and 15 meter band, as you can see here. And as we are going also increasing the frequency, we see some white areas that it will not cover. But of course, if your antenna is in that area, it will pick the closer matching, that it will be here or it will be here, right? So it will match, but not perfectly to one-to-one. And this is the last graphic for the 12 meter band and the 10 meters band. And that's it, folks. Thanks for watching. Remember, to subscribe, and if you like the video, please hit the like button, and until the next time.